And now, okay. A very good afternoon to sir. My name is GOKULAKRISHNAN, son of YOGANATHAN, and my ID number is EB19035. So this is my teammates, ISHVAB, SELVAM, SOORIYAR, RAVINDRAN, and Muhammad SHAHRUL bin RUSLAN. So our assignment title is about line coding. Okay. So we're going to explain you about the unipolar NRZL and NRZI line coding. Okay. So first of all, we need to understand what is line coding. Line coding is a digital signal to be transformed with the information where we manipulated its amplitude and the discrete signal. So how we can produce line coding is by using a PCM. So PCM is fed into the system so that it can produce line coding. So PCM is like analog to digital converter where it converts the waveform into the line coding part. So PCM is used for transmitting analog data. It works by converting analog signal into the digital form. By using PCM, it's possible to digitalize all forms of analog data, including full motion video, voice, music, telemetry, and etc. So that's why PCM is commonly used in most of the industry compared to other like PAM and PPM, because PAM and PPM is mainly used for amplitude manipulation and for the position manipulation. Okay, next slide. Okay, advantage of PCM. As I mentioned earlier, PCM is one of the most commonly used analog digital converter in most of the industry, because in PCM they have a sampling, they have a quantization, and they have a encoding where each of particle will do their own work. Okay, so advantage of PCM: robustness to noise and interference. Because compared to PAM and PPM, PAM we manipulated its amplitude, PPM we manipulated its position. So there is a lot of noise interference, but in PCM there is no noise interference. And second is efficient regeneration, and third one is efficient SNR and bandwidth. This is because in PCM we will manipulate its bandwidth and its discrete signal so that it can produce the line coding for the specific purpose or for the local area network. And number 4 is uniform format, and number 5 is secure. Okay, line coding. So the function of line coding. So line coding normally used for the local area network. The main purpose of the line coding is synchronization, error detection, and error correction. So as I mentioned earlier, line coding is produced by using PCM. PCM is fed into the system. Okay, this is a unipolar NRZ. So unipolar is only one voltage level. In unipolar, there is no negative. There is only positive and zero. That's why you can see that there is no negative in the figure below. So 0 means there is no value, 1 means there is a value. So NRZ is known as a none-return to 0. Initially, unipolar scheme was designed as a none-return to 0 scheme, where the positive voltage represents bit 1 and the 0 voltage represents bit 0. Signal does not return to 0 at the middle of the bit. So that is the biggest disadvantage of the unipolar, because it is not a self-clocking NRZ. And next slide. Okay, second, this is a polar NRZL and NRZI. So polar means there is a 2 voltage level, which is we can use positive as well as negative. So you can see 0, 1 and negative 1. Okay, so there are two types, which are NRZL and NRZI. None return to 0 level. NRZI is a data encoding system in which binary 1 is represented by negative voltage and binary 0 is represented by a positive voltage. In NRZL, if the binary value is 1, the line will be at positive side. If the binary value is 0, the line will be on the negative side, as shown in the figure below. None return to 0 inverted NRZ will invert the signal if the binary value 1 is encountered. In NRZI, if the binary value is 1, the signal will be inverted. If the initial signal was 1, it will be inverted to negative 1. If the binary value is 0, there will be no inversion. If the signal is 1, it will be still at. Okay, that's all for me. My friend going to explain you about the methodology part.
Okay, thank you, Gokul. My name is Surya, unlike Ravindran, and my metric ID is EB19045. And now I'm going to explain about the methodology. So, for this assignment, we use two types to get the line coding. Two methods to get the line coding. The first one is by using Python coding. The second one is by using MATLAB. I'm going to explain about Python coding first. Okay. So to start, we have to import the library matplotlib, and we have to name it as MTP so that it will be easier for us to write the code later. And then we also have to import the library NumPy, and we have to name it as NP. So after that, the second step is to define the NRZL, which will be used to define the whole line of code for energy L, and later we can input the binary into that from the GUI later. And to get the plot, to get the value of amplitude, we have to make an if-else statement. As you can see from line 6 until line 12, okay, that's the if-else statement. Okay, let's say if the value for energy L, for unipolar energy L, if the value is 1, the line coding will be on top, which is at 1. And if it's 0, it doesn't go to -1, but instead it stops at 0 because it's unipolar. And the code from line 13 until 24 is used to plot the graph. And now let's go to another unipolar NRZI, which is non-return to 0 inverted. For if-else statement for this, we have to make some changes a bit, because inversion will occur when the binary value is 1, and there will be no inversion if the binary value is 0. So we have to make an if-else statement which correlate to that statement. So let's say for this example, if the data value, which is the value of binary, is 1, we have to make an inversion, in this case from 1 to 0. And if it's not 1, which means it is 0, it continues at 1, it continues. And if the value of 0 is true, there will be no inversion. And if the value of inversion is false, a value of 0 is false, which means it's not 0 but instead 1, inversion will occur. And the coding line from line 44 to 57 is for plotting the graph. And the code from line 59 to 67 is the simple GUI that I made. Okay, what it does is the code will ask the user for decimal value. We have to put the decimal value. For this example, I put 86, and the decimal value will be converted into binary value, and the binary value is the data that we'll be using for our main coding. So the binary value will be used in the main coding, and the line code will be plotted. And now let's go to the polar energy L and energy I. Actually, the coding for polar energy L and energy I are almost the same as unipolar energy L and energy I. The difference is we have to make some changes at if-else statement for both energy L and energy I coding. The if-else statement for energy L, we have to change from x equal to 0 to x equal to -1, because polar energy, it doesn't stop at 0, it goes to -1. As you can see at line 11, before this, the unipolar energy was x equal to 0, but here is x equal to -1, which means if the binary value is 1, it's at, depending on the amplitude that we put in this code, and in this case, it's 1. If the binary value is 1, then the line coding will be at 1. And if the binary value is 0, it does not stop at 0, but instead it will be at -1. As you can see, the line code from 13 until 24 is to plot the graph. And now let's go to polar NRZI. As I said before, it's almost similar to unipolar NRZI. The only changes we have to do is an if-else statement, where it is if the value is at 1, inversion will occur, but it doesn't go to 0, it goes straight to -1. And if the value of 1 is false, which means it's not 1 but instead is 0, there will be no inversion, which can be said the same for 0. If the value of 0 is true, there will be no inversion because it's 0. If the value of 0 is 1, there will be inversion occur, and it will be gone through. If it's a -1, it will go to 1, and if it's a 1, it goes to -1 because the value of binary is 1. And the code from line 44 to 57 is for plotting the graph. And as I said before, the code from line 59 to 67 is for as a simple GI to get the decimal value from user, which will be converted into binary and used as data for both of the codes. The result will be shown later. That's all from me, and my friend will take over from here. Thank you very much.
Okay, thank you, sir. So, my name is Muhammad IZHAM RUSLAN. ID number EB19205. So, I will continue for coding, line coding from MATLAB, Unipolar, and RUSLAN. So, first, the binary value is started as shown in the picture. Like you can see 01010110. The code at line 3 is rated to be a simple GUI to get the value of amplitude from the user. If the user want to amplitude to be 4 or any other value, the, the user just need to enter the value while the coding is running. So the the code from line 5 to 11 is right to change the value of amplitude for the line coding according to user input. So the coding from line 19 to 23 is right to be a if-else statement that change the line coding according to the binary value. If the binary value is 1, the line coding will be up as it will be at 0. So the code from line 2 to 30 is used as the plot to plot the unipolar and RZ line coding. So let's continue for polar and RZL and RZI. So the code for polar and RZL is almost same as unipolar and RZ, except the code at line 9 should be changed from 0 to negative amplitude. So that's the line coding will go until negative value instead of stop at 0. Which is the binary data is right shown in the code line 2. From the code line 10 to 27 is the if statement which take care of determine the position and exact I line coding. When the value in binary is 1, there will be inversion in the line code. If initial the line is at 1, it will be at negative 1 after the inversion. Else, if the value of the binary is 0, there will be no change in the line. So the code from line 29 to 34 is used for plot the line coding. So it's all from me. Thank you.
Okay, now for the results. Okay, this result is from the Python Unipol NRZ. As you can see here, the code asks the user for decimal data input, which is 86. And 86 will be converted into binary value and used as data for the line coding. As you can see here, when it's 0, it's a 0. When the binary value is 1, it's a 1. And I should say that the value of amplitude can be changed however we like according to the user inside the code. I choose 1 and 1 as the amplitude. So when the value is 0, it's a 0, and when the value is 1, it's at 1. And for the this the result, and the right side is the result for NRZ in I, which is also mean as non-return to 0 converted. When there is 0, there will be no inversion, but when there is 1, there will be inversion in the line coding. And now the Python code result for polar NRZ and NRZL and NRZI. Instead of stopping at 0, it goes until negative 1. And it's the same for the right hand side, which is and non-return to 0 inverted. And that's all from the result from Python. And now the result from MATLAB. This is the result for unipolar NRZ from MATLAB. When the value is, as you can see, it doesn't go until negative 1 but stops at 0 because it's unipolar NRZ non-return to 0. And this is the result for polar NRZL and NRZI. Instead of stopping at 0, it goes until negative 1. And if the value is 0, and if the value is 1, it goes until positive 1. And for NRZI inverted, it's the same principle as the one before. When there is 1, inversion will occur. When there is 0, there will be no inversion. but instead of stopping at 0, it will continue until -1. And if the user wanted the amplitude to be 2, it will be from 2 until -2. That's the difference. And that's all for the result. Thank you.
Okay, hello, my name is ISHVAB of SELVAM. My ID number is EB19063. So I'll be handling the conclusion for our project. So in conclusion, we have gained a lot of knowledge by doing a lot of research and experimentation into this project. We can conclude that the research that we have done proves that there is no need for further modifications or changes to enhance the performance of this project. We have learned that line coding has become a necessity in this technologically advanced world. Almost every modern devices requires line coding to encode or decode data. For example, some mobile phone system uses code division multiple access, also known as CDMA. Each phone will be assigned to a code sequence that is approximately uncorrelated with the codes of other phones. Therefore, the aim of this project is to prove that through studying and proper research, anything could be proven true. So that's all from us. Thank you very much.